In this video, I want to demonstrate how to securely use your API keys in a typical web application. I will be using Next.JS 14, one of the most popular modern-day web application framework based on Node.js. In the previous video, I showed you how to secure your API by generating keys and attaching them to your APIs within API Gateway. Then, we configured the API headers to test out your API. Keys are a great starting point for securing your API on the internet. But knowing how to use the keys securely in a web application requires additional provisions. Modern web-based applications require interaction to APIs to enable dynamic behavior and work with data fetch, unlike the types of web applications we had in the 90s and early 2000s, where users would have to move between web forms to forms and submit buttons. APIs, like the ones we created in the previous exercises, are extremely powerful, but knowing how to access these APIs without exposing these API keys can be a challenge. In this video, I will walk you through a modern React-based full-stack web application I wrote. This application is designed to call the same API to fetch a list of people from the database. I will first show you how to fork my repository on GitHub, then clone this repository and deploy this on AWS Amplify. I will show you how to modify this application to point to your API, pointing to the Lambda function which you deployed and secured in AWS API Gateway. I will later show you how to use techniques like server-side rendering, a built-in capability within the Next.js framework to secure your API keys. I will also show you how to use client-side rendering, which will require the API keys to travel to the browser where this secret API key is compromised. I will discuss how you will need to enable CORS on your APIs to overcome browser security frameworks which would prevent making calls to your API which is not originating from the same URL as your web application. If you do not have an account in GitHub, let's go ahead and create an account now by going to github.com. GitHub is a cloud-based service that hosts version control using Git. It allows multiple developers to collaborate on projects, track and manage changes to the code, share code and documentation, and maintain various versions of their work efficiently. GitHub is a platform for code hosting and collaborative development, offering tools for reviewing, sharing, and managing open source and private projects. It supports all the functionalities of Git, along with additional features such as issue tracking, feature request, access control, and wikis for every project. Once you've signed up into GitHub, let's go ahead and clone my repository by going to https://github.com/github.com/person-next-ssr. On this page, click on Fork. You can keep the default as it is. It's automatically filled out the same name of the repository. Keep it exactly as it is. Click on Create Fork. For this next step, if you have not installed Git already, go ahead and download it from the official website. Now that I am in my Windows terminal, if you're on Mac, open up the Mac terminal. Let me go into the downloads folder where I want to download my latest source code. I've created a folder called Bootcamp. You can see my Bootcamp folder is empty. Let me use my git command. I'm just going to paste the URL. You can find the URL of your cloned repository from the top of your browser. Now it is downloading all the source code. Let's have a look. It has successfully downloaded the code. Let me go into this folder. You'll see all the code in this directory. Now, Visual Studio Code is launched. Let's go ahead and take a look at the code, and let's go ahead and check out the README file. And then from the README file, we'll look at the next instructions of how to run this server. Let's go ahead and create a .env file. So to do that, let's click on this button here that says click new file. I'm going to call it .env. Now let's go back to the README file, look for instructions. For this simple demonstration, let me just copy this content and paste that in the .env file. And let me click Ctrl S to save. And then next, let me go ahead and click on Run Terminal. And let's do that. And let's go back to the README file. You'll see the first instruction is to type in npm install. Let me do that. What this will do is install all of the necessary dependencies. If you have not installed Node.js, I would strongly recommend go ahead and download the latest version of Node.js. Okay, my dependencies are installed. Let's go ahead and see how do we run the server. To run the server, you need to type in npm run dev. So let's go do that now. Okay, my server is running and has started. Once you've set up your .env file, let's go to localhost 3000 to have a look at the application. You'll see 3 links. Let's have a look at first the Get API for People. Let's click on that. There you go. This is showing me the results of running the API/person. Keep in mind, this API is using Next.JS API. This is a very simple mock API. We will be replacing this API with the API that you've created in your API gateway using Lambda functions. So you'll see the 2 links. The first one says server-side rendering and the second is client-side rendering. Let's click on server-side rendering first. You'll see I have a table here, and in this table I display first name, last name, phone number, and date of birth, and I have 2 records that's coming in from the API. If I go back and click on client-side rendering, it looks very similar. In fact, the front end is identical other than the logic on the back end. So let's have a look at the differences between the two. Behind the scenes, What I'm doing first is clicking on right click, click on inspect, click on network, let me refresh this URL to see what's happening behind the scene. Notice we have a API call in our list. Let's click on this. I'll make this bigger so you can see this better. This application here, person-c, has made an API call. HTTP localhost 3000/API/person. It's made a GET request and it's gotten a 200 OK. You can see the response. The response from this API has 2 records. Now let's go back and look at the server-side rendered app. Let's go ahead and click on server-side rendering. Let's refresh the screen. Notice on the server side, we still get the same output, but there is no API call that is made on the browser. Now, let's deploy this web application on AWS Amplify. Let's go ahead and log into your AWS console. To get to AWS Amplify, just simply click on search and type in Amplify. So let's get started. Click on Amplify Hosting. Click on GitHub. At this point, you may need to authorize GitHub to connect to AWS Amplify. I've already gone ahead and given the permissions. Go ahead and do that now. Now that the permissions are given, you'll be able to see all the repositories. I'll select my repo, click on the main branch, click Next. Let's have a look at the build settings. So that's all pretty standard. Click on Advanced Setting, type in Node 20.9.0. This is very important because we're using Next.JS 14, which requires a higher version of Node.js. Next, go ahead and complete the environment variables. For now, I'm just putting in some placeholders. We will come back and replace the next public API URL to a public-facing value. We will then replace this value to the API endpoint that you created using Lambda functions. And also, if you have a key, go and put that here. Now click on Next. You can see the custom image, the 2 environment variables. Let's click on Save and Deploy. Okay, I can see that the build has failed. I know exactly why. If you recall, I have provided the URL as localhost, but that will fail for the client side. Let's look at our logs. All right, I'll go back into environment variables. I already have a domain name, so I'll go ahead and go to environment variables, click on manage variables, and I want to replace the host name to the one that Amplify has. Let me click on save. Okay. Now let's go back. Let's click on build. Let's click on redeploy this version. Great, the build has been successful and it has been deployed. Now let's go ahead and test drive this. Click on the domain. There we have it. Let's click on client-side rendering. Great, I can see the results. Let me inspect. Let's click on network. Let's reload this page. There you go. Let me make this a little bit bigger. You can see the request has been made to the API from the browser back into the server that's running on Next.js. And if I click on server-side rendering, let's refresh this page. You'll see there is no API calls, but we've got the data. Let's click on API GET request. There you go. You've got a result. So let's recap. In this video, I showed you how to fork and clone my GitHub repository and how to run this locally on your machine and then deploy it on AWS Amplify. You have also seen how to set the URL of the API using the environment variables. For now, I have a mock API that's running on Node.js. Let's swap out this Next.js API with an API using AWS Lambda and AWS Gateway. First, I will create a new Lambda function. I will copy and paste the core logic from the API in Next.js and turn this into my Lambda function. Since my Next.js app is built using TypeScript and Node.js, I will be creating my AWS Lambda function using Node.js and JavaScript. To get started, let's go back to AWS console and go to AWS Lambda. Let's create a function. Let's call it getPerson function. Let's create a function. Great, my function is now created. Let's scroll down. Let's remove the default code and replace it with the code that I wrote. Let's click on deploy. Now let's test. Let's call this the test event. Click save. Okay, great. Our test is a success. Now that we have our AWS Lambda function giving me the same results as my other API, let's attach this to an API trigger using API Gateway. Click on Add Trigger, choose API Gateway, create a new API, select HTTP API, and let's choose Open for now. Let's click on Additional Setting and enable CORS, and then click on Add. Great, our trigger is set up. Now let's look for endpoint. Let's click on this endpoint. Fantastic. We now have our replica endpoint. Now that we have our API in API Gateway giving me the same results as the Next.js API, let's rewire the app to point to this API instead. Let's start by going back to the AWS Amplify, click on our app, click on environment variables. We will go ahead and change the API URL. Click on Manage Variables. Let's copy and paste our URL endpoint for the API Gateway. Let's click on Save. Okay, now this is updated. Let's go ahead and redeploy this. This will take a few minutes. Okay, great. This is deployed. Now let's click on the URL in the domain and let's check out our app. Fantastic. Let's start checking our API first. Okay, our original API works. Now let's check out our server-side rendering page. Great, we can see the data, which means our API works. Now let's click on client-side rendering. Notice there is no data displayed. So let's inspect and see what is happening. In the network, you can see the getPerson function is red with a cause error. Let's unpack this. Let's unpack why we got a cause error in our browser when we try to call an API from the client side to a URL which is different from this Amplify hosted URL. Cause, or cross-origin sharing, resource sharing, is a security feature implemented by the web browser to restrict web pages from making requests to a different origin than the one from which the current page was served. Now, let's go back to AWS API Gateway page in AWS console and let's configure our cause. Click on our API. From the left-hand navigation panel, click on cause. We need to click on configure. Here we need to add a wildcard for access control allow headers. Put in the wildcard and then click on add. Let's also select get method and now click on save. Now let's get back to the app. Now let's test out our client-side rendering app. Let's click on inspect. We can see the data. Click on network. Let's refresh. This time you can see the getPerson function is working well. Let's have a look. We got 200 response and we can see the JSON payload. We now have a fully deployed web application deployed using AWS Amplify. By now, I hope you have a better understanding of the behavior of the client-side rendering and server-side rendering, as well as how cores work and how to control your cores security within AWS API Gateway.